Today, we're going to talk about the most abundant biological entity on Earth, but it may not be what you think. I'm Yvette Biddle, and this is the Phages in the fight against superbugs.
Phages are a type of virus that infect and kill only bacteria. Their formal name, bacteriophage, translates directly to bacteria eater. These guys outnumber bacteria on the planet 10 to 1, with an estimated 10 to the 31st phages on the Earth right now. Phages contain most of the genetic diversity in your body, and they consist of 4 main parts. The head, which contains their DNA and is generally shaped like a 20-sided dice. The sheath, which holds their structure together. The tail fibers, which mediate connections to bacteria cells. And the receptor, which is specially designed to match a specific bacteria.
Phages float around their environments waiting to encounter their specific host bacteria. Once they find it, they use their receptor to bind to its surface. Then the sheath helps inject the DNA from the head into the cell. Here, phage has 2 paths ahead of it. It can follow the lysogenic cycle, where it combines its DNA with the DNA of the bacteria and slowly reproduces each time the cell divides. Or it can follow the lytic cycle, where it quickly hijacks the cell's machinery and makes dozens of copies of itself until the cell bursts, releasing all the new phages and starting the cycle anew. This has major implications in the fight against superbugs. Superbugs are harmful bacteria that are resistant to antibiotics. It is estimated superbugs will kill more people than cancer by 2050 as antibiotic-resistant bacteria evolve and spread. But phages are a new hope in the fight against superbugs. Phages are bacteria's original enemy and have already proven useful in fighting superbug infections. In fact, the first patient in the US to be cured by phages recovered from a coma induced by an antibiotic-resistant infection in 2017. There are pros and cons to the use of phages for treating bacterial infections. Phages may have less side effects than antibiotics because they kill only the bad guys, while antibiotics kill both the bad and good bacteria in your body. Also, phages have the ability to evolve alongside bacteria, outsmarting new defenses, and they've been doing it for millions of years. However, phages are harder to use than antibiotics. Because phages are selective killers, it can be hard to find the perfect phage to cure an infection. Scientists address this by making phage cocktails. Phage cocktails contain a few different types of phages, carefully selected for a patient's specific bacterial infection in a process called screening. These phages are selected from phage libraries all over the world. Unfortunately, this process can be time-consuming and expensive. Our phage libraries contain only a tiny fraction of all the types of phage on Earth, and this treatment faces many regulatory challenges. But scientists are moving quickly to change it. The technology available today makes phage therapy more feasible than ever. There are people all over the world looking for more phages that can cure more of our bacterial infections, and there's been a massive push towards funding phage therapy research. Phages have the potential to change how we approach infections and save millions of lives.